Hello everyone, hope you're doing and welcome back to my channel. Today we're at day 5 of the January Daily Leetcode Challenge and we have a very good question in front of us. This is the exact question that you will be getting in multiple contests. If I remember correctly, around 2 to 3 weeks back, this similar question came in one of the weekly contests that we had on Sunday. So this is exactly similar question. The topic is exactly the same, which is difference array. Okay. So once you know this topic, you can solve multiple questions on this. So it's a totally new concept. If you are aware of this, only then you will be able to solve this kind of questions. Otherwise, you will be only able to try the brute force. Other than that, you won't be able to optimize it further. Okay. So this is a very new concept. So without wasting any of your time, let us quickly dive into it. I will be showing you both Python and Java solution for it. And before that, we'll be also going through in details of what is this difference array and how it works basically. So what is the idea behind it and what is the result that we're going to get with it, how it is optimized and how it is better than the brute force. Okay. We'll learn all that thing. But yeah, before that, let's see the question. So as you can see, we are simply given a string and we are given some shifts. Okay, in each of the shift, you will see that is in each element of the shifts array. We are having each element is having three items. Okay, that is three integers. So yep, as you can see, each member is having three integers. That is the only thing that I want you to show before starting the question. Okay, now let us begin the question. So it is 2381 shifting letters and it's a part two of that question. You are given a string S of lowercase English letters and a two integer array shifts where shift y is equal to these three things. Okay. So these three things are there in each of the shifts. Okay. For every I, shift the character in S from the index start of I to the index end of I, both inclusive, forward if the direction equal to 1 or shift the character backward if direction equal to 0. Okay. They have given so many things that I'm damn sure you will not be able to understand this. Okay, when we'll see the example, it will be very clear to you. But for now, what you have to learn is this start will tell me the index from which I have to start taking the, in the given S. That is, if you see here, the string S is given to us in this particular string. From a particular index I have to start doing something, and the same we have to do till the index end. Okay, so this is the starting point of the starting index of that, and this is the ending index of it. Okay, and this will tell me the direction. Okay, so now let us see the examples. So okay, see this part. Okay, after this question, if you see, they are just mentioning what is that. Okay, they are just telling you what is the meaning of this direction. Direction one means you have to go in the forward direction. Forward means, for example, you are at A, so A will become B and B will become C. Similarly, Z will become A and so on, right? If it is 0, that is, if the direction is 0, we have to go in the backward direction. Okay, backward means, for example, if you are in A, it will become Z. If you are in Z, it will become Y. Okay, and then something like that, so on. Okay, return the final string after also shifts are applied. So let us see the example now. See this part. Here it tells that you have to start from index 0 and you have to do it till index 1. Okay, so index 0 and index 1 are these two. Okay, in these two I have to do the shift in a backward direction, because whenever see the direction equal to 0 means backward, the direction equal to 1 means forward. Okay, just remember this part. So from index 0 to index 1, I have to go in the backward direction. Okay, so this is index 0, this is index 1, so these two should be now going in the backward direction. Backward means this A will become Z now, this B will become A now. Okay, so after applying the first shift, okay, after applying this particular first shift, ABC will become this. Okay, ZAC. What happened? A went to Z, B went to A. Clearly see here, this is the same thing happened. Okay, now the next shift will be applied on this. Okay, so what is the next shift? This is the one. Okay, that is go from index number 1 to index number 2 and move in the forward direction, because the direction equals to 1. Okay, so index number 1 and 2 are these two. Now I have to move in the forward direction. So what that means, so A will become B and C will become D. Okay, so if you see, this is going to be the final answer after applying the index number. That's the second shift, right? Yeah, now after applying the last shift, okay, this shift will be applicable on index 0 till index 2. Okay, I have to move in the forward direction. So if this is the starting string, so index 0 to index 2 means the whole string. Basically, I have to move the whole string in the one direction forward. Okay, that is, Z will become A, B will become C, and D will become E. Okay, uh, as you can see, this is the final answer. I've written the final answer. Okay, so this is all about the question. I've already explained some of the edge cases. If Z is there, you have to move forward, it will become A. Similarly, if A is there, you have to move backward, it will become Z. Okay, these are the only two things that you have to know. Okay, yeah, other than that, everything is easy. If you see the, yep, if you see the constraint, it is around 10 bar 4. The length of the string is going to be 10 bar 4, and it's going to consist of all lowercase letters. Okay, so these two things are very important. Now let us begin the question. As I mentioned, this whole topic revolves around a algorithm called the difference array algorithm. Only if you are aware of that algorithm, you will be able to optimize the solution. Otherwise, you will only be able to solve it in a brute force way. Okay. So what is the algorithm? Let us now go and see. So see, the idea here is, instead of, for example, see here they are saying 0 to 2. So idea here is, it each basically each in brute force, what you will do, you will go to each shift, go from this range, that is the starting range, to the ending range, and apply the shift. Okay. Similarly, you have to do for each of the each of the shifts. You have to go in the array for those starting and ending indexes, and you have to apply the shift. So instead of doing that, what we'll do is we will apply all the shifts at once. That is in O of n time, in a single pass over the array, we will be applying all the shifts. Okay, this is the algorithm that we'll be using. This is called the differential algorithm. So please pay attention what is happening. We are going to use the concept of a prefix sum. Okay, so this is just a modification of the prefix sum approach. I will tell you what is happening here. Just pay attention. So okay, let me zoom in before and let us begin. Yeah, as you can see, this is my difference. Sorry. As I mentioned, it's a modification of the prefix sum. So here also we'll be starting with all zeros initially. The length of this difference is also going to be the same as the length of the given string to us. Okay. So in the example one I'm trying to trace, so that's why the length I've kept as length 3. Okay, now let us begin. So this is the first shift that need to be applied. This is the one. Okay, I have taken from the example. Now see what is happening. I have to start from 0th index. I have to go till index number 1. I have to move each one of them in the forward direction, sorry, in the backward direction. 0 means in the backward direction. Okay, so what I will do, I will go to this 0th index and I will subtract it by 1. Okay, in this array I will go to the 0th index, I will subtract it by 1. Okay, so here as you can see, I just added a -1. Okay, then the ending index is 1. Okay, so whichever is the ending index, always go one above that. That is, since it is 1, I will go to index number 2. Index number 2, I have to reverse whatever I did here. So here I added 1 as 1. So in the index number 2, I have to go and add a +1. Okay, I added a +1 here. Okay, now this is my difference area after applying the first shift. Okay, what is that you will get to know, but just wait for now. We'll get to know everything once we do the prefix sum. Till now we have not done the prefix sum. Okay, now we'll go to shift number 2. Okay, same thing we'll do. In this case it is 1, so the we have to move it forward. See, here it was 0, so we did a -1 initially and then we reverse it. Here it is 1, so we'll do a +1 initially and then we'll reverse it. Okay, so where you have to go, we have to go to index number 1 and do a +1 there. Okay, so this is the index number 1, I will do a +1 there. It will look like this after that. Okay, now this is the ending index. Go to ending, so always you have to do a +1 here. That is, go to index number 3 and do a -1, because you did a +1 initially. Now you have to do a -1. So go to index number 3 and do a -1. Since index number 3 is out of this range, so we avoid that. Okay, as simple as that. If it is out of the range, simply avoid it. Okay, fine. So next, what you have to go? We have to go to this range now. Okay. So what is this? Go to index number 0. Remember this again. We are moving in a forward direction. Okay. So here, if you say the direction is positive, okay, direction is positive. So here the direction is positive. That's why we'll do a +1 initially, and then we will reverse it. Okay. So we have to go to index number 0 and do a +1. So index number 0 is like this. We will do a +1 here, so it will become 0 after that. Okay. Because it is already -1, we are doing a +1. It will become 0. Similarly, go to index number 3 now and do a -1. Since index number 3 is out of the range, we are not going to do anything. Okay. So this is the final difference array. Now we will do a prefix sum over it. Okay, so what the prefix sum, that is, for each index I, add the previous value to this index. Okay, so that is 0 will be added to 1. Okay, it will become, okay, just a second, 0 will be added to 1, it will become 1. Similarly, the result here, that is 1, will be added to this particular 1, it will become 2. So this is how the array is going to look like after doing the prefix sum. So what this array means, this array is going to tell you what is the number that you have to add to each of the characters now. So what that means is, here it is ABC, right? It is ABC. That is, for A, okay, for A, you will have to add 0. That is, A will not change in the answer, A will remain as it is. So as you can see in the answer, A is remaining as it is. For B, you will have to add 1. That is, B will be moving forward by 1 unit. Okay, set this, B will become C in the answer. As you can see, it becomes C in the answer. Similarly, for C, if you talk about, C is going to be added by 2 units. That is, C will be moving forward in the forward direction by 2 units. So C will become CDE. So it will become E. So you see in the answer, it became B. So this is how the difference, the array is going to help us. That is, for each of the shifts, we are going to add the value there in the array, and then after doing processing all the shifts, we are going to do a prefix sum, and this prefix sum will tell me for each character how much steps I need to move forward or backward or whatever it is. Okay, it is going to tell me that. Okay, so the net, that is, if you see, we did not apply each of the shifts individually. In the brute force, if you try to do, you will have to apply each of the shifts individually in the array. Okay, that is again and again. See, for example, here index 1 and 2, here also it is 0 and 2. So idea here is something is common in these two index, right? Something is common here and here. So those things will be processing again and again. So that is not the optimal way. So what we are doing here currently, we are storing this all in our this particular array, difference array, and then we are going to do a prefix sum. The prefix sum, after taking the prefix sum, it will tell me how much diff I need to add in each of the characters and to get the final answer. Okay, this is going to be my approach. Okay, so this is the difference area. I have shown you example. Please pause the video if this is not clear to you. Please pause this video and see, it's nothing. See why? See, okay, I will tell you the logic now. What is happening? See here. Okay, let me take this particular example. Okay, so here what we did. remember one thing. See, you will have to understand what is prefix sum okay, initially. Prefix sum means that the current value is carried forward. Okay, the idea here is we want all the values in these two indexes to have a -1. Okay, so that is the reason why what I did is in the index number 0 I added a -1. Okay, so when I do the prefix sum, what will happen? -1 will come here also. Okay, and since we want only in these two index we want a -1, that's why a index index next to 1, okay, that is 2, I add a +1. So the idea here is when I do prefix sum here, what will happen? This -1 will get nullified because of this one. Okay, so that is the basic idea. But yeah, this will remain -1, this will also become -1, and it will get nullified here. So if you do a prefix sum of this at this stage, what will happen is these two will remain -1, and after that this will become 0, and this is exactly what we need. Okay, this is exactly what we need because of the shift. So we want index 0 index 1 to be moved backward by one step. Okay, that is exactly what we need. So this is the basic idea behind the difference array prefix sum approach. Okay, now let's see how to do this question. So I hope you understood everything out of this question, because I have taken at least 5 minutes to explain the whole algorithm, so that now you can solve it on your own. Okay. So let me show you my algorithm. I will show you both Java and Python solutions. First of all, I'm taking the length. Okay. So look, let me show you the output how it looks. Initially, at each step we'll be calculating the prefix sum, and then we will be doing the sorry, the difference array we'll be calculating, and then in the last difference array we'll take the prefix sum, and then according to this we will see each original character is going to be mapped to which character. Okay. In the answer, for example, B got mapped to C because the diff is 1 year. Similarly, C will be mapped to E because the diff is to positive 2 year. Okay, so that is how we are going to get the answer, right? So let me show you my approach. I am going to create a prefix sum array initialized with 0. All the values are having 0, and the length of that is going to be n. Okay, I'm going through each of the shifts. Okay, initially I'm going to each of the shifts and see if the k, that is the last character, the last value here. Okay, the last value, that is the, they are calling it a direction. So if the direction is 0, then we have to move in the reverse direction. If it is 1, we have to move in the positive direction. So I am initializing the shift with 1, and if the k is 0, I am making shift equal to -1. Okay, now shift is the actual number in which we will have to move. Okay, as simple as that. Now what I'm doing, see here, prefix sum of I plus equal to shift, that is, this is I, right? The starting index is I. So at this particular I am going and doing a plus, that is, I'm adding the shift can be positive or negative one. Okay, it could be either, it depends on the value of k, which is the direction. Okay, as simple as that. Remember, k is this one. Next, I'm just checking whether j plus 1 exists or not, because remember j is the ending index. Okay, so in order to nullify the effect of this in the j plus 1 index, I have to nullify it. Okay, so whatever was the shift that was added, I have now added a minus shift there. Okay, as simple as that. Here we added the shift, here we have to subtract the shift, as simple as that. Okay, but it has to be in the j plus 1 index. Remember, we want the effect till j, so in the j plus 1 index it has to be nullified. Okay, for that reason we are going to j plus 1 index and we are nullifying it. Before that, we are checking whether the j plus 1 is in the range or not. If it is not in the range, then we don't have to do anything. Okay, as simple as that. Then I'm printing it at each time. Okay, so let me show you the output of this first. So as you can see, yeah, these are the ones. So for index 0 and 1, yeah, as you can see here we added -1, and the this particular 1 plus 1 is 2, so index 2 we added a 1. Okay, as simple as that. And then the same thing here. Okay, at index 1 I added a +1, and at index, okay, it will become index 3. So index 3 we cannot do anything. Okay, it is out of the range. Similarly, index 0 I added a +1, so it will become 0 now, and again it is index 2, so we have to add 1, which will be index 3, which is not in the range, so we can't do anything. So this is the final array. We'll have to take the prefix sum here. Okay, if we are getting like this. So now let me show you how I'm taking the prefix sum. So this is the part where I'm taking the prefix sum. Okay, let me show you what is happening. See here. So yeah, the prefix sum of I is equal to prefix sum of I plus prefix sum I minus 1. Okay, as you can see, prefix sum of I is equal to prefix sum of I plus prefix sum of I minus 1. Okay, this is how we are taking the prefix sum, and these things are not related to the general algorithm, but these things I'm doing because I want to optimize my solution. Okay, so what is this? The idea here is, since the characters are, there are only 26 characters, right? Since we're taking only small case characters, I hope I've showed you that initially also, the letters are going to only smaller case. Okay, so the idea here is, even if it is greater than 26, okay, please try to understand this fact. Even if that the prefix sum, whatever value we are going to get here, if it is greater than 26, it's of no use to us. Okay, because after 26 again the same reversal will happen. Okay, the same thing will happen. So the idea here is, we are going to do, if the prefix sum is positive, do a percentage 26. If the prefix sum is negative, do a percentage minus 26. Okay, these things will ensure that we are not unnecessarily doing the calculations, because see, idea here is a to z. Okay, this is going to be a round, right? So even if it is 26 or anything more than that, it's of no use to us. Okay, because we need a value within 26 always. Okay, so if it is exceeding 26, that is plus 26 or minus 26, you'll have to bring it back. That is the basic idea of doing this percentage. If it is positive, do a percentage 26. If it is negative, do, that is the prefix sum is negative. For each index, you have to do a percentage minus 26. Okay, this part is very very crucial. If you don't do this, you will not be able to get optimal solution. Again, its solution may get accepted, but that will not be optimal. Okay, so this step you will have to always include because it is coming from the logic of the question. Okay, since there are 26 characters, so it doesn't make sense. See, for example, if we have 27, so that is same as having 1. Okay, because if you see 26, that is 27 you are getting by 26 plus 1, which means index number 1 again. Okay, that is A. So that is the basic idea, right? Now the perfect sum is done and we are done with the stage. Now comes the part. Okay, see this part. Here I'm starting from index number 1 and going to n minus 1. So what about index number 0? Because see what is happening, for each perfect sum of pi I'm adding the previous index, but this I cannot do for index number 0 because there is no previous value for index number 0. So for index number 0, okay, these two steps I'm going to do separately. These two steps, that is a percentage 26 step, I'm going to do separately. If the prefix sum of 0 is less than 0, do a percentage by minus 26. If it's greater than 0, do a percentage by positive 26. Okay, these two steps are doing separately for index number 0, right? Then I'm printing this array for you. As you can see, this part, this is the one. Yeah, and after that comes the most important parts. Here I'm creating a new answer and then I'm storing the values. In Python, this is the where difference will come in Python Java solutions. See, in Java what is happening, you can simply typecast, you can use the external typecasting, that is int and character. You can change, you can change them. That is, you can just cast it and you can change the integer to a character and so on, right? Or integer to a character, character to integer, something like that. But in Java, sorry, in Python, what I'm doing is I am storing the ASCII value of this. Okay, because remember, in ASCII value is interchangeable in Java and C++, but in Java, sorry, in Python, we'll have to do it manually. So here I'm going to take I'm using this particular operator. This is called the ordinality operator. This will tell me the ASCII value of A. Okay, so small a. Similarly, this will give me the ASCII value of Z. Okay, I'm calling it as ordinal position of A, ordinal position of Z. That is the ASCII value of A and ASCII value of Z. Okay, then I'm going through each of the ranges of N. Okay, I'm doing a ordinal position of S of I. I'm getting it. That is whatever the ordinal position of the original string in the ith index, I'm getting it. There I'm adding the prefix sum of I. Okay, as simple as that. This is going to give me some answer. Now, if this answer is greater than the Z, that is, it is exceeding Z, so we'll have to go back to A. So I'm using this. Okay, what I'm doing, I'm subtracting the ASCII value of Z with the current ASCII value. Then I'm adding it with ASCII value of A. Okay, so the idea here is we have to roll it over. Okay, if it exceeding that, it has to come back to A again. Okay, that is the basic idea. Okay, similarly, the other cases, if it is going below or the ASCII value of A, the idea here is it has to see, if it is going below ASCII value of A, it has to go back to Z, right? So that is the basic idea. If it is less than this, what you have to do, subtract it from ASCII value of A, you will get a negative value. That negative value you have to subtract from ASCII value of Z. Okay, as simple as that. So that you are going to get. So this ASCII value and this value will be within the range of A to Z. Okay, as simple as that. Then what we are doing, we are simply doing, we're converting back to character. Remember, ordinal position will give you the ASCII value. CHR will give you a real character out of the SQL. Okay, as simple as that. So we are getting the real character again, and that we are adding to our answer. And at each step, we are basically showing as of is the original character, and it got converted to which character at last. Okay, this is what we are showing, and this being added to the answer. We are returning the answer at last. Okay, let me quickly run this and show you. So as you can see here, it is showing what is the original character. Okay, and what it got converted to after applying all the shifts. Okay, so as you can see here, B got converted to C because at last we are going to change it by 1, and similarly C got converted to E because we are moving it by 2 units in the forward direction. Okay, so this is all about example number 1. You can go through example number 2 also. It's almost the same. Okay, as simple as that. Yep, you can go through that also. But yeah, this is the final solution. You can segment it, just comment the answers out and segment it. It will be accepted. This is one of the most optimal solutions. If you talk about the space and time complexity, see here the time complexity will be processing these two strings. Okay, this part and this part. So based on the length, so the final time complexity is going to be O of n plus m. Okay, where n is the length of the string and m is the length of the shifts. Similarly, if you talk about the space complexity, we are using this particular array whose length is same as delta of the length of the shift. Okay, s. So it is going to be O of n. Okay, as simple as that. So that is all about this particular solution. Now coming to the Java part, since many of you are very interested in Java solutions, I am always including Java solutions now. See this part. Here only difference will come in this particular part. Okay, the last part, this particular part, only the difference will come here in Java. Okay, see this now. I'm first of all calculating the n, then I'm creating a prefix some integer array of length n, then I'm filling them with zeros. Okay, this is the way you should do it. Arrays.fill method. So yeah, basically, see in Leetcode, what I mentioned, these libraries are already imported. But if you want to do it in your local machine or whichever laptop you're using, in that you have to import the libraries. Okay, so you can just import java.lang.star. Okay, okay, those particular things you can just import it, and that will be enough. Okay, yeah. Okay, sorry. It will be java.util.star. Okay, because java.lang will be for math library for doing the max and main function. This will be java.util. Okay, so you can just import and do a star for that. That's java.util.star, and this library will be a part of it. Okay, as simple as that. Next, what we are doing, we are just calculating the shifts. Okay, we are going through all the shifts. Okay, and then what I'm doing, I'm taking I, J, and K. So see here how much I have to type here, but in Python how easy it is. Okay, I'm simply taking here, as you can see, I, J, and K in shifts, but in doing the same in Java, sorry, yeah, Java, I have to do this much things, right? So yeah, you can do that. You have to declare shift is called one initially. If the direction is reverse, you have to change the shift to -1. Then, as I mentioned, this is exactly same as the algorithm that we discussed in Python. Okay, this is exactly the same algorithm like this. We are doing it. Okay, as simple as that. The same thing that we did in Python, we are doing it here. Okay, that's why I'm not going to the detail of this step. So after this part, basically the array is now populated. Now we have to start the prefix sum. Okay, so this is how we're taking in the prefix sum. That is for each index I, starting from index number 1. We are adding the previous value to it. Okay, as simple as that. Then this part, as I mentioned initially in Python also, if the prefix sum after all these additions come in less than 0, you have to do a percentage 26 with -26. Okay, that's percentage with -26. If it is greater than 0 or equal to 0, do a percentage with 26. Okay, as simple as that, right? After that starts the real game. Okay, now yeah, as I mentioned, this is for index number 1. That's from 1 to n-1. So for index number 0, we are doing this particular step separately. Okay, this is the exact step that we are doing separately for index number 0. Okay, so if it is exceeding 26, we have to bring it back to within the limit of 26. Okay, 0 to 25, we have to bring it back. Okay, that's what we are trying to do. And now here comes the difference. In Python, we simply created an answer like this, but in case of Java, the best thing to do will be using string builder. Remember, you should not use string for these purposes, because remember, strings are kind of a constants. So the idea here is, if you add a character to a string, what happens? No, the original string will remain as it is. A new string will be created. All the contents of the original string will be copied to that, and then the new addition will be made. Okay, so that is why that is not the ideal approach. So if you want to do any string modification, that is insertion, deletion, and all that part, okay, that is if a string is going to increase and decrease in size and all that part, or if you are building a string from starting, then it's always better to do it with a string builder approach. In one of the previous solutions, I've already shown you that there is a huge difference in time coming when you do the string with string and when you do the string with string builder. Okay, it's always better to do such things with string builder, where you have to do modification in the string. Okay, it's always better to use string builder. That is the only thing that I want to tell you. But yeah, there are differences where you have to use this. Strings are basically thread safe. That is, while you're doing a multi-threading, strings are the best. But if you're not doing multi-threading and you have to, there is a scenario where you have to build the string. That is, you have to keep changing the string in between. It's always better to use string builder. Okay, as simple as that. So yeah, you should be knowing the in scenario in which this thing should be used. Okay, as simple as that. Now the same thing I'm doing that I did in Python. I am creating an integer to store the SQL of these things. Okay, the SQL of A will be stored it here, and the SQL of this character Z will be stored in this. Okay, now I'm going through each of the indexes. Okay, what I'm doing is I'm taking the character at ith position of the given input as, I'm adding the yeah, the prefix sum of I to it. Remember, this is a character, this is an integer. But since the target is also integer, so the ASCII value of this particular character will be taken. With this, the value here will be added, and then we are going to store the answer in an integer. Okay. Now all the remaining things will be integer. See here, if it is exceeding z, that is we have to bring it back to a. So for that we are subtracting it from z, and then we are adding the ASCII value of a. Similarly, if it is below a, we have to bring it back to z. Okay. So I'm subtracting it from ordinal position of a, that is ASCII value of a, and then I'm adding it. Remember, this part will be negative number. Okay, so this negative number we are adding to the SQL of z. Okay, as simple as that. Now, since this number is a integer, okay, remember this is integer. So but in the answer we have to append the character. So I'm is doing explicit typecasting, and then I'm appending it to my answer. Okay, which is a string builder. Okay, so I have to convert it back to a character, and then I have to append it. Otherwise, you will get to see that there are integers value present in the answer. Okay, in the string format. That is not something we need. So this particular integer we have to externally convert. That is the external typecasting we have to do with char, and then we have to append it to our answer. And finally, while returning, I'm doing answer to string, because if you see here, the return type marks as string. Okay, for that reason you have to convert it back to string. So the best way to do this is you use the string function, to string function. So yep, let me quickly run this and show you. As you can see, this is clearing again all the test cases. I've already submitted this solution and it worked. So in today's solution, we learned a totally new algorithm called the differentiary algorithm. I've given you in detail explanation for that. I've given you a live example of how the things happen, and I've already given you the hint of why this logic works. The idea here is we are going to add a integer here. Okay, that for example in index number 0, we are adding a -1 here. Okay, and we want to nullify it after these two indexes. Okay, after index number 1 we want to nullify it, so we go to index number 2 and we add opposite of that, because here it is -1, so I'm adding a +1 here. So whichever thing we're adding, we have to reverse and add it here. Okay, as simple as that. So this way what will happen is when you take the perfect sum, these two things will become -1, but after this, this particular portion, it will be nullified, because -1 and +1 will cancel each other, it will be nullified. So that is how it works. Okay, the idea of nullifying works here because we're taking the prefix sum. So that is a basic idea how this difference array works. It's a modification of the prefix sum approach. Okay, as simple as that. So yeah, friend, that was all for this particular video. I hope you enjoyed my solution. You got to know something new. I hope so. This is something very important. Remember, there are a lot of questions coming on this topic. Even in some contests, they are asking this kind of questions. So please be good in this kind of topics. Be very logically clear what you are doing, because if you know just above and the just in for the knowledge sake, if you are knowing it, this is not enough. You have to implement it with your, take a pen and paper, implement it and see how it works, so that in interview you are very confident. Okay, here if I apply, I'm definitely going to get the answer. So once you say to the interview that I'm going to apply this, you have don't have to return back. That is, you don't have to backtrack from your words. Okay, so that is something that I want to tell you. Be very confident with whatever you're going to do in interview. So yep, that was all for today. And if you like my efforts, please subscribe to the channel. This really gives a lot of motivation to continue further. Till now, I've seen a very good response from all of you in terms of the number of questions that you are solving in, yeah, in the January. But yeah, maintain that it's not that only in the first or 2 months of 2025 you have to do that. You have to do that every day. Okay, as you can see, around 7,000 people are currently online now, and they are solving this. So I am assuming that you are going to be one among them. So yeah, and that was all for today. And yeah, that last one thing that I want to tell you is that, see here, the acceptance rate, okay, it is up to 50%. The idea here is, if you know this simple solution, that simple algorithm, you can solve this kind of question and you can be ahead of the rest. Okay, that is, you can be ahead of the other 50% of the people. Okay, so yeah, among 100, only 50 solutions are being accepted. So if you want to be in that 50, you will have to know this kind of algorithms. So yep, so this is just to motivate you to come in those particular brackets. And yeah, that was all for today. If you like my efforts, please subscribe, and see you tomorrow.